This video shows definitions of antiderivative integrations, and also talks about differential equations with how to find general and particular solutions for differential equations. And lastly, talk about Fundamental Theorem of Calculus. First, antiderivative. What is antiderivative? So big f of x is the antiderivative of f of x if the derivative of big f of x equals to the small f of x. For an example, sine of x is an antiderivative of cosine of x. It's because if you take the derivative of sine of x, you get cosine of x. Another example, x squared over 2 is an antiderivative of x because the derivative of x squared over 2 equals to 2x over 2 equals to x. Now for the notations, if we say that sine of x is the antiderivative of cosine of x, then we can say that the integral of cosine of x dx equals to sine of x when sine of x is an antiderivative of x. Keep in mind, if you take the integral of cosine of x dx, you get sine of x because sine of x is an antiderivative of x, and you also plus a constant. The reason is, if you take the derivative of sine of x plus a constant, it will give you the function cosine of x. And because the derivative of the constant is 0, so that means the derivative of sine of x plus c, when c is a constant, equals to cosine of x. That means the integral of cosine of x dx equals to sine of x plus c. Ex here is the differentials of the functions. Cosine of x indicates that the input values of this function is x. The next example is we already know that x squared over 2 is an antiderivative of x. So then we can notate that the integral of x dx equals to x squared over 2 plus c. And again, c is a constant. So if you take the derivative of x squared plus 2 plus c, you take 2x, you get 2x over 2 plus 0 equals to x. So the integral of x dx equals to x squared over 2, and we can check it by taking the derivative of the antiderivative to see if it takes back to the original functions. And then we have differential equations. So differential equations are equations that involve derivative. Right? For an example, the derivative of y equal to x squared minus sine of x. And in this differential equations, we also have a point is called initial values, initial point. The initial points here will help us find particular solutions for these differential equations. So if we have these equations and we want to solve for y, right? We want to solve for the function y such that the derivative of y equals to x squared minus sine of x. Then we integrate both sides. So we integrate a derivative of y and then integrate x squared minus sine x dx. When you integrate a function, you should have a dx at the end. Okay. So the integral of a derivative of y serves as equals to y. So the integral of the derivative you can think as the inverse of the functions, right? So if you integrate a derivative, it should cancel out this derivative. So then you have y as the only values left on the left side. And then when you integrate to the right side, you will get the integrals of x squared minus the integral of sine of x. So since the integrals of x squared equals to x cubed divided by 3, and the integral of sine of x equals to negative cosine of x. So the negative sine of x, the integral of negative sine of x should equals to positive cosine of x plus c as a constant. And then this is y equals to x cubed divided by 3 plus cosine x plus c is the general solutions for this differential equations. If you want to check whether this is correct or not, you can take the derivative of x cubed over 3 plus cosine of x plus c to see if you get back to the original function x squared minus nx. So the derivative of x squared, x cubed over 3 should be 3x squared over 3. Cancel the 3, you get x squared. Derivative of cosine of x should be negative sine of x. So x cubed over 3 plus cosine of x plus c is the integrals of x squared minus x. And this is the general solutions of this differential equations. And once you have the general solutions, you can plug the initial values into this function to find the value of c. So the initial value is 0, 1. That means when x equals to 0, y equals to 1, x equals 0, y equals to 1, and then you can solve for c. In this case, c is 0. Thus, the particular solutions for this differential equations is y equals to x cubed over 3 plus cosine of x is the particular solutions for this differential equations with the initial values of 0, 1. The fundamental theorem of calculus help us find the integrals of a functions with bounds. So you can see that here you need to have d of x. So the integrals of f of x bounded from a to b, d of x equals to the antiderivative functions of f of x at b subtract the antiderivative functions of little f of x at a. In this case, the functions f of x is continuous on the closed interval from a to b, and also big f of x is the antiderivative of small f of x. Let's look at an examples. If I want to find the integrals of square root of x dx from 1 to 2, this is also called a definite integral. The indefinite integral, that is integral that will give you a finite number. Okay. So before finding the definite integrals, we need to find the integrals of square root of x dx. Then I convert square root of x to x raised to 1/2 dx. So then I can use a power rule to find the antiderivative of square root of x. So the power rule says if you want to find the integrals of x to the n dx, it's going to equals to x raised to n plus 1 over n plus 1 plus c. So in this case, my n is 1/2. So the integrals of x to the 1/2 is x to the 1/2 plus 1 divided by 1/2 plus 1. And I evaluate these functions from are 1 to 2. 1 is the lower bound here, and 2 is the upper bound here. So 1/2 plus 1 down here is 3/2. And if I bring it up, I flip it and take the reciprocals of 3/2 is 2/3. And then the x here, I replace 2 as the upper bound, 2 to the 3/2. And I subtract 1 raised to 3/2. And so this is the definite integrals that I find for this definite integral here. This is the values of this definite integral. Integrations that has bounds, lower bound and upper bound.